Hi friends, I'm Prashant and you're watching Qlikview tutorials on my channel Oja Consultancy Tech Video. Today we are going to discuss about Qlikview data architecture. Qlikview data architecture is mainly of the two type, two-stage architecture and three-stage architecture. So let's begin. Two-stage architecture. Two-stage architecture split into four layers: source layer, extract layer, QED layer, presentation layer. So source layer contains Excel file, text file, CSV file or database connections. That is the reason we said it is source layer, because it gives only the information about the source. Now move to extract layer. Extract layer contains Qlikview document who has a extraction script, and using the extraction script in extract layer, data is pulled from source layer and stored into a QED layer. So most of the transformation is always advised to perform at the extract layer, because the benefit of that is you can easily maintain the changes. Second, it will be a fast response rather than doing all your expressions or all your transformation at the presentation layer. Third point is, when you are doing this transformations, possible that you might need some filters, you might need to change some business rules, so that the unnecessary data extraction or unnecessary data pulling from the source will be avoided. Means your this QVD layer will always keep the perfect and necessary informations for your presentation layer. That's the reason we always suggest perform as much as possible transformations in the extract layer. Now move to the QED layer. QED layer contains QED files. This QED files is specified file format for the Qlikview, and these are generated using the extraction script at extract layer. This file is 50 to 60% compressed of the original data and doesn't contain any graphics thing. So it's only contain text file. That is the reason the size of the QED is always lesser than the actual source. Another benefit of the creating a QED layer is reusability of the data, because you can see at the bottom in a presentation layer, which is a final layer in this architecture, they are using multiple QEDs, and even one QED is shared by multiple reports. That is the reason usability is maintained. Reusability of the data is maintained here and it's presented here. Now is the presentation layer. So we already discussed presentation layer is holding all your Qlikview applications for the end user. Now this structure, two-stage architecture, is mainly designed for less transformation or no transformations application. Means where either we have very few transformations applied, or we are not applying any transformation, just extracting the data and presenting the applications. So you might have a question that what is the reason then why we are creating so much of the things, even we know that we can directly connect our QVW application, means final presentation layer application, to this source layer. We can perform that, but when it's come for the maintenance and reusability of data, we need to follow two-stage architecture. Now we'll move for three-stage architecture. So in a three-stage architecture, you can see there are two more layer has been added. Transformation layer, transformation QVD layer. Means source layer is exactly as it is, extraction layer is as it is. Now the previous one, which was we are saying that QVD layer, now it's converted to a base QVD layer. Fourth one, transformation layer, transformation QVD layer, and presentation layer. So these two area is the additional, right, layer. What is the use of these two layer and why it is different from two-stage architecture? Even though few of the advantage are exactly same. The main reason is useful for regular transformation. Because of these regular transformations, we always suggested to maintain three-stage architecture because we assume first layer of the QVD is purely exact copy of the data source without any transformation. As you can say, base layer is a straight copy of data source. So when we are performing the high level of transformations or very complex transformations at this transformation layer, it will process very fast because this processing is not happening at the source file. This processing is happening on the QVD files. So any transformation when we are doing in a QVD, it's always faster than doing any transformation on the direct source file. That is the reason we have segregated and created two more layers as a transformation layer and transformation QVD layer. Where in a transformation QVD layer, you can see that denormalized QVD, aggregated QVD, segmented QVD, reduced QVD. So this image also give you the information that we have very specific and regular transformation, more and complex transformation we are performing for the end user. So that is the reason we suggested three-stage architecture rather than going for the two-stage architecture because transformation is always very frequent and it's a regular process. Now, as we already discussed about two-stage architecture and three-stage architecture, it is easily understandable what is the reason for using a two-stage architecture and three-stage architecture. That's all, friend. I hope you liked this video. Kindly share and subscribe for next video. Thank you all.